Everybody to our coast-to-coast safety share that we have with Workplace Safety North in Northern Ontario. Tom, do you want to say a few words before I introduce Kaylee?
Sure, thanks very much, Bill. Good afternoon, everyone. I think I've met most of you before. I'm Tom Welton, the Director of Prevention Services and Education Programs for Workplace Safety North. And we once again appreciate the opportunity to connect with your committee to share some information of keen importance to ourselves in Ontario as well. From a mobile equipment pedestrian interface issue in the sawmill operations, as well as other forest industry related operations, it has been an issue in Ontario as well, as you can imagine. And 3 years ago, we had multiple fatalities in our sawmills in relation to pedestrians being fatally injured and walking through a sawmill yard and being struck by a loader. So we're keenly interested in hearing a bit more regarding the study that's been completed and the Bowtie Analysis. And I would like to introduce our chair of our advisory committee, Dave Barry, who's also on the line. I don't know if you had anything else to add, Dave, or just a wave. That's good enough too. Okay, I'll turn it back to you, Bill. Thank you.
Thanks, Tom. Just a few housekeeping items. We do request that people stay muted until they want to speak, and it tends to run a little bit better that way. And if we have any technical difficulties, both Tammy and myself can get the slide deck up where it was left off, and we'll try to get Kaylee back online or on a phone call. So right now I'd like to introduce Kaylee Rainier Brown. She's the Director of OBEX Risk. I first met Kaylee back in 2020 when we were starting a project that was initiated by WorkSafe BC by integrating process safety management into the wood pellet sector. And they had the requirement for the operations to do Bowtie Analysis. At the same time, we had also were co-sponsors with WPAC and Dalhousie University for a research paper funded by WorkSafe BC to build better bow ties for the forest sector. And we were actually very lucky to be able to pair up with Dalhousie University and Kaylee, who became our bow tie facilitator. She has participated in 3 other projects since then. Plus, we have another innovation at work. I think they call it something different now that we're applying for next year's, which is a continuation of the work we've done with the Bowtie Analysis on mobile equipment, where Kaylee will be doing some research on integrating inherently safer design, which you'll hear about during this presentation, for the mobile equipment pedestrian interface. So that being said, I'd like to introduce Kaylee Rainier Brown, the superstar bow tie facilitator who really made my life easy for the last 3 years. So go ahead, Kaylee.
Well, thank you very much, Bill. Very kind words, and it's not very often that I'm told that I make someone's life easier instead of harder. So at least someone's saying that. I appreciate that. And good afternoon and good morning to everyone on the call. Some familiar names, some new names. I'm really looking forward to sharing some of the findings from the project with you today. I think that the talk actually, I flip-flopped on this, but I think that the talk really, it is a presentation, but ultimately I want to have a conversation and a discussion with you guys about challenges that you're having and how you really think that the lessons learned can be applied to your operations. So if you have questions during the presentation, please feel free to enter them into the chat. I guess the GoToMeeting doesn't have the hand raise feature, but enter them into the chat and I'll actually opt to answer your questions during the presentation. We have a lot of time blocked off today, so I think there's something to be said for answering questions in the moment when the whole group is together on a certain topic that's being covered. So if you have questions, enter them into the chat, and I'll just go ahead and answer them there. I think that's a great catalyst for a discussion and sharing some ideas and perspectives here today. And then obviously we have plenty of time at the end as well to have a discussion too. So yeah, without further ado, I guess I'm going to be sharing with you a best practices safety share today, and it's an overview of Bowtie Analysis of mobile equipment pedestrian interface in sawmill operations. So the purpose of today's presentation is to really provide an overview of the project that has been completed to date. And that was conducting a Bowtie analysis of the MEPI, or mobile equipment pedestrian interface hazard, specifically in sawmill operations at this point. And this is part of a larger report that has been prepared. So the outline of today's presentation, it will begin with an introduction into the hazard that you guys are all intimately familiar with, which is mobile equipment in your different kinds of work sites, whether they be sawmill operations, wood pellet operations, or mining, or other types of industries that may be within your specific HSA. I'll provide a background into Bowtie Analysis, how we conduct the workshops, and I'll provide an overview of inherently safer design, like Bill mentioned, ISD, and the hierarchy of controls, because that was some additional support and some additional analysis that I conducted for this Bowtie Analysis to kind of do a bit more of a deep dive into the Bowtie and some of the current approaches that are being used for barriers and risk reduction measures for the mobile equipment hazard. I'll then provide an overview of the results of the Bowtie analysis and some discussion around that. So specifically an evaluation of the different barriers that are being used that were identified in the workshop, as well as some different threats and scenarios that can lead to those struck by incidents. And I'll summarize some areas for improvement for this area that were identified by the workshop team. And we'll close off with a brief literature review that I completed of MEPI hazards in some other industries that I was able to find in literature, and some recommendations and closing statements. And I've also added, I'm going to put you guys in the hot seat and ask you guys some questions to help generate a discussion around maybe some of the challenges that you guys are facing, and how you, maybe some areas that you think you'd like to improve and move forward with. So a little introduction about me, like Bill mentioned, I am a specialist in Bowtie Analysis, inherently safer design. I am the owner and director of Obex Risk Limited, so I'm based in Halifax, Nova Scotia. I graduated from Dalhousie University, completed my master's in March 2020, and really the rest is history in terms of collaborating with WPAC and other industries to help improve process safety and some health and safety initiatives. So I specialize in industrial risk management, like we're going to be talking about a lot today: Bowtie analysis workshops, inherently safer design workshops, critical control management, which some of the folks on the call today will be very familiar with. That was a process that was rolled out and conducted in the wood pellet industry that really focused on identifying some key controls and how to make sure they're effective. So I can help support that. And I also conduct other process safety research and development services and combustible dust hazard consultations. So I really pride myself in providing personalized service and providing practical and using forward-thinking approaches, really cutting-edge approaches, and new ways to reduce risk and ultimately help protect personnel, your business, and the environment. So MEPI in sawmills. So as you're well aware, sawmill operations involve a wide range of different types of mobile equipment and pedestrian activities. So the term that I've used already quite a bit is MEPI, or Mobile Equipment Pedestrian Interface. And that really is kind of the collective term that refers to the interaction of mobile equipment and pedestrians. So obviously the MEPI poses a risk of loss-producing struck-by incidents that can lead to injuries and fatalities. So in British Columbia, the Manufacturing Advisory Group, or MAG, identified MEPI as a key area for improvement of risk management. So I was approached to conduct and facilitate a Bowtie analysis to help evaluate the MEPI hazard in sawmill operations. So this was completed in a workshop with the collaboration of the BC Forest Safety Council, production workers from MAG companies, as well as members of MAG. A little bit more about Bowtie analysis. So it's a type of process hazard analysis, or a PHA tool. And really it's a systematic way to identify and evaluate hazards associated with a range of operations, really to facilitate and identify ways to control and manage those hazards. So for Bowtie analysis, for MEPI, Bowtie analysis can really improve the understanding very thoroughly and systematically of how those struck-by incidents can happen, what the different barriers and controls are in place to help prevent those incidents from happening, and taking it that one step deeper and really examining weaknesses in those barriers. So identifying how those controls are less effective or can be degraded. And then identifying controls that are in place or should be in place to help ensure that barriers are more effective and would be more reliable and would perform as needed when needed. The Bowtie analysis workshop that we conducted also involved a discussion and identifying areas for further investigation that have the potential to improve safety and address some of the current gaps and current issues that were discussed. And following the workshop, I undertook some additional work to evaluate barriers with respect to the hierarchy of controls. So we'll talk about this more in the next slide, but that is the hierarchy of controls is the preferred order of consideration of risk reduction measures. So if you've ever seen that inverted pyramid, you'll see it a lot in this presentation. So you might see administrative and PPE or procedures on the bottom of the pyramid, and at the top you have minimization and substitution, and engineered is in between. Well, that's exactly what we're applying here. So you want to try to eliminate your hazards first prior to adding on those administrative and engineered controls. So that was an evaluation that was completed after the workshop. I also identified some frequently used barriers, so barriers that appeared and that were used in the Bowtie a lot, and that would kind of help identify those as areas for prioritization. And additionally examined some of the threats that would lead to an MEPI incident, and to really understand which duties and which pedestrians are most affected by the MEPI risk, again, to prioritize those target areas. So Bowtie analysis. I don't have a full, the Bowtie that we developed for MEPI was very large, as you'll see more kind of as we discuss it. So this is actually the only picture of a Bowtie analysis that you'll see in today's presentation, but this will give you a good idea of kind of the approach and how it can be so valuable and so powerful for this hazard. So it analyzes different scenarios and conditions that can lead to a loss of control and lead to undesired consequences. So the general structure is illustrated in this figure here. So the Bowtie is made up of different elements. That's what we call them. So in the yellow and black box here, you have your hazard. So that's the thing that has the material or condition that has the potential to cause harm. So in this situation, it's mobile equipment at a sawmill. So that's the hazard. And then we have the top event, which is the middle knot of a bow tie. If you were to picture a bow tie, the top event is the middle red and an orange circle. So that's the thing that you're really trying to prevent. So that is your MEPI incident. On the left-hand side, in these blue boxes, you have your threats. So they are the conditions or the scenarios that can occur that could lead to an MEPI incident. So it could be a kiln attendant is in the yard and there's mobile equipment driving by. It could be visitors on site. It could be chip trucks being present and moving through the yard, so on and so forth. And then on the right-hand side, we have consequences. So if an MEPI incident were to occur, if that top event were to happen, what would subsequently occur? So you could have injuries and fatalities, business interruptions, legal implications, so on and so forth. So these are the consequences on the right-hand side. Now, the barriers, these are kind of the, they look like tires almost. Those are the black rectangles that are on the right and the left side. So on the left side, you have your prevention barriers. Those are the controls that are in place that would prevent the top event or an MEPI incident from occurring. Those could be, some examples are designated walkways, wearing of personal protective, high visibility equipment, getting into some more inherently safer design approaches or barriers, reconfiguring and redesigning areas so there's more space between mobile equipment and pedestrians, performing tasks a different way that maybe wouldn't require either pedestrians or mobile equipment, for example. And mitigation barriers are on the right-hand side. So if an incident were to occur, what barriers are in place to reduce the severity or likelihood of a consequence? So for the consequence of injuries and fatalities, mitigation barriers include things like first aid, muster points, emergency response by third parties, so on and so forth. And where the rubber really hits the road with Bowtie analysis is these degradation factors and degradation controls. So those are in the yellow boxes. So like I mentioned, taking a little bit of a deeper dive and examining how those barriers can be less effective. If you're familiar at all, maybe some of you are with the Swiss cheese model that's like commonly used as like a layer of protection sort of analogy. So you have the holes in the Swiss cheese, and if those holes happen to line up, that is when you could have an incident. So this kind of is the same idea. If you have small holes in your barriers and they're not working exactly as they should be all the time because they've been degraded, then that could lead to an incident. So for personal protective equipment, for high-vis vests, maybe they're dirty, maybe they're worn out and they're not that highly visible anymore, maybe someone isn't wearing theirs, so on and so forth, right? And then for other incidents like, gates or lights that need to be activated by a person in order to, say, block off a path or indicate to an operator that they need to do something. Again, things can go wrong. Maybe the environmental conditions make it difficult for a mobile equipment operator to see. Maybe the pedestrian doesn't press the button. Maybe the light is burned out. There's so many different things that can go wrong. So a Bowtie analysis really captures that. Specifically in the degradation factors element. And then the degradation controls shown here in the other sort of tire, those are the controls that you can have in place to make those more effective. So they can be things like audits, inspections, preventative maintenance, training, so on and so forth. Maybe using additional controls that rely less on human input and factors to make those barriers more effective and more reliable. So that is an overview into Bowtie analysis and a bit how, that's a very high level description of how we used it to analyze the mobile equipment pedestrian interface hazard. So inherently safer design and the hierarchy of controls. I made reference to the inverted pyramid. Here is a graphic here in figure 2. So inherently safer design is on the top of the pyramid. It's the most preferred, it's the most effective, followed by passive engineered, active engineered, and administrative. So inherently safer design, I'll cover that more in the next slide, but at the core of it, ISD, inherently safer design, focuses on the elimination of hazards and the treatment of hazards at the source, rather than only relying on add-on equipment and procedures. Passive engineered, that is, those are add-on equipment that don't require detection and action. So something like a concrete barrier, you can install it, it's an add-on device, but it's not set it and forget it, but it doesn't have to detect something and then react to conditions. Unlike your active engineered, so a really good example of that, not for mobile equipment, but a smoke detector, right? It detects smoke and it activates an alarm, and that could indicate to people to leave a building. So that's a really good example of an active engineered barrier that's very familiar to everyone. In the context of mobile equipment, that could be a gate that automatically detects the presence of a pedestrian and closes the gate so the pedestrian couldn't come through, for example. And administrative controls they're also called procedural controls. So those are your safe work procedures for carrying out tasks a certain way, for wearing PPE, so on and so forth. So effective risk reduction involves the use and the integration of all of the types of controls in the hierarchy. So implementation of inherently safer design, engineered equipment, as well as those procedural measures. So let's talk about inherently safer design some more. It is based on 4 principles: minimization and substitution, as well as moderation and simplification. These are some nice graphics that kind of demonstrate what exactly we mean by those principles. So minimize is potentially self-explanatory, at least in the context of mobile equipment. You could redesign areas and work sites to minimize or eliminate the presence of pedestrians in the same area of mobile equipment. It could also be minimizing or eliminating mobile equipment in the presence of pedestrians, right? You're really just minimizing the hazard. A substitution, an example of that is using alternate process methods or alternate ways of doing things that could eliminate or minimize the presence of mobile equipment or pedestrians. For moderation, an example of that in this context is to relocate activities that involve pedestrians away from mobile equipment. So with moderation, the hazard still exists. You're just creating a safer separation distance, essentially, between them. You're changing the conditions around the hazard, if you will. And for simplification, an example of that is to redesign processes and equipment to make it hard to create a hazardous scenario due to operating or maintenance error. So simplification really brings in aspects of human factors and really changing the ways that you do things to make it easier for operators and personnel, making it easier for them and less likely to fall short to human error. And a nice little graphic of how each of those types of controls can be used to manage MEPI hazards. So again, working all together to help reduce the risk. So redesigning work areas to minimize the mobile equipment and pedestrian interaction. For passive engineered, we have installation of cement barriers, active engineered installation of automatic gates that are activated when personnel are detected. And for an example of an administrative control, wearing your high-vis PPE. So you can see how all of those are very necessary and they're all complementary to each other and work together to help reduce risk. So let's talk about the MEPI Bowtie workshops. That was conducted on site in Prince George, British Columbia. It was completed in the beginning of April, and it took place over 2 daily 8-hour sessions. It involved 8 subject matter experts of diverse background and experience and subject matter expertise. That included mobile equipment operators, maintenance personnel, heavy equipment mechanics, health and safety specialists, as well as supervisors and managers. And like I mentioned before, these were all comprised of production workers from MAG companies and members of MAG. So something really key for Bowtie Analysis is having a diverse group of personnel that are bringing their own experiences and perspectives and insights to the workshop to really identify key areas of concern and identify issues that they have and that they experience with this particular hazard. So having the right people in the room is really key. It's excellent though for engaging and sharing and learning. So all in all, the workshop was a great success. So I led the workshop as a facilitator and scribe. So I proposed all the questions, I helped trigger the discussion and identify those Bowtie elements that I highlighted earlier. And Bill Laternus was on site and he provided some key workshop assistance to help coordinate on-site logistics, engage with key stakeholders. And Bill knows a little something about Bowtie analysis at this point, so he can ask some great questions and help collect some great information. So now it's the point where I get to provide you with an overview of the results and discussion of the Bowtie analysis. So there were 3 hazards that we identified in the workshop, and they were based on the areas of the sawmills. So we broke it into the MEPI within lumber activities, within log activities, and within production and storage indoors. So Bowtie analysis, as you can obviously tell, it's very detailed, it's comprehensive, it takes a fair bit of time. So in the 2-day workshop, we really had the opportunity to really focus on one key hazard, and the priority of the group was the MEPI within the lumber activities. So that's what I'm going to be speaking to a lot for the rest of the presentation, was the analysis of that particular area. The top event, like I mentioned, was the mobile equipment pedestrian incident. And we defined an incident as including all struck by incidents involving mobile equipment and pedestrians. So it also includes being struck by a load, a rock, a board, not only a pedestrian being struck by mobile equipment. And incidents also include domino or cascade effects that could occur from something like lumber going through a wall that was initiated by mobile equipment. The Bowtie analyses are built using the Bowtie XP software. So the figure that I showed you earlier of the generic Bowtie analysis is that's from Bowtie XP. So it's a commercial off-the-shelf software. So those files are available and they're available in Visio format as well. They can be converted into Visio. And some supplementary material was also developed as well. So let's get into the really juicy parts, if you will. So what did we really find in these workshops? So I was able to analyze all of the different barriers that were identified by the workshop team and analyze them with respect to the hierarchy of controls. So I qualitatively assessed the type of barrier and identified if it was administrative, active engineered, passive engineered, or inherently safer design. So as you can see in the red box that I've included there, there were 851 administrative barriers identified out of a total of 1,138. And you can see there were 2 active engineered, 7 passive, and 1 inherently safer design. So you can already kind of see that that indicates that most of the barriers that are currently being used that were identified in this particular sawmill Bowtie workshop are administrative controls. And we know from the hierarchy of controls that is the least preferred, right? Because it relies the most on human action and human input. And also in this table, you'll see potential administrative, potential active, so on and so forth. This table just also highlights the number of barriers and their type that were identified by the workshop team in the area of for things to consider for additional measures that could be included. So those are also in the barrier. And it is also interesting that, again, the majority of them that were identified, 156, are potential administrative. So you can still see that there seems to be a bit of reliance or tendency to still be looking at administrative controls. So overall, my recommendation coming out of this is to try to move higher up on the hierarchy. And that's kind of back to what Bill was saying, a potential research project that's being pursued is to kind of identify how more inherently safer design can be incorporated into this particular hazard. So yeah, very interesting overview kind of the different barriers that are being used and kind of the heavy reliance currently on administrative controls. So I do want to put the question to you guys now. I think this is a nice point to kind of pose the question to you. Consider the current approaches and the current barriers that are being used at your work sites. So maybe reflect on what types of barriers are you using, and are you using a greater proportion of some than others? So I do invite, yeah, Dave, I see you just unmuted yourself. Anyone please speak up if you want to kind of share your reflection.
You're still muted there, Dave.
So I can add something, Kaylee, Shane Newcomb from Canfor. Yeah, I think we'd fall in the same category or same weighting, highly administrative. Some of the challenges with some of these mills, they were built or rebuilt and added on over many decades, and having a redesign to eliminate or substitute is challenging in some cases. We rely heavily on admin. I'm curious where you put the and we've gone heavily into Vision Plus, a pedestrian detection. Where would you put that into a control? Is that, I've my opinion, and I've heard other things. Where would you put those pedestrian detection system in?
Yeah, that's a good question, Shane. I guess I do have an additional question for you. So I think Vision Plus came up in an earlier conversation. So for that particular barrier, so it detects the presence of a pedestrian, and does it just sound an alarm to the mobile equipment operator, who then has to take an aversive action?
That's correct, yeah. Yeah,
so even though there is an automated component to that, due to the fact that in order for the incident to not occur, the operator actually has to take action, that's an administrative control. And I will say, so I caught myself when I talked about the smoke detector. You know, the smoke detector in everyone's house, it's automatic because it detects the onset of smoke, but it ultimately does rely on people to leave. A better example would be like an automatic, like smoke detect and deluge, for example. So having an automatic water suppression. So yeah, in this situation, Shane, and this is the device that was brought up in discussion, it's, in my opinion, it's administrative. If there was pedestrian detection and then there was something automatic that would separate the operator, the mobile equipment operator, from the pedestrian, then it would be active engineered. But because it's currently relying on the operator to do something, it's active. So is that your opinion, Shane?
Yeah, that's been my stance as well, and that logic makes sense to me.
Okay. Okay. Good. That's excellent. Do you have any other questions, Shane? And I guess I will, and that's kind of part of the research question, and part of the challenge with inherently safer design is how do you, we know that the most benefit of inherently safer design is seen when it's at the design stage. You haven't invested the capital, you haven't designed things, it's easier to choose inherently safer design routes at that stage. So I guess are there specific challenges that you're seeing, like from your operations in terms of implementing inherently safer design? Like, is it that there's not enough space on the work site to reconfigure things? Like, what are some challenges that you're having with that?
Yeah, I suppose it's space. It's just the proximity. Like the planar building might just require you, without any alternative routes, to put an area that you can't physically blockade. So often, in some cases, we chunk it up. So it would be controlled in some sections, but then there's a section where you rely on just a sign and or some active light or something that you press to do it. So it's so I'd say it's more. I'd say it means more just where your location of certain areas is just not in the right spot. So
yeah.
In one case, we've moved the mobile shop into a completely different area and rerouted traffic, and we had all the space to do it, and it's a success story. But there's lots of our mills that we just cannot do that. So you're living with 60 years of design.
Yeah, no, that's a really good point, Shane. Thanks for sharing.
Yeah, no problem. Thank you.
Appreciate it. Does anyone else have anything that they'd like to add? Any other kind of challenges? Are their experiences the same as Shane?
Yeah, I finally got mine unmuted.
Hey, Dave.
Yeah, same situation in our facility, 100-year-old facility. Trying to change the design is hard. We've got a combination of passive and active engineered and administrative controls that we've put in recently. A lot of it around the same time as BC was having issues with interactions and was looking at that. We had the same issue here, or at least paying more attention to it. I would say, I guess we've had interactions for many, many years, but suddenly putting more focus on it. So putting cement barriers out, putting in flashing blue lights on the forklifts for clamp trucks, and then putting in the requirement for high vis PPE everywhere somebody went, not just in specific zones.
Yeah, all really good points, Dave. Thanks for sharing. Yep. Anyone else have anything they'd like to add? Anyone from the wood pellet operations that are here today? Just gonna check the chat. Okay, perfect. Okay, well, thanks for the insight and the really good discussion. Yeah, and to everyone else, I would just encourage you to reflect on that and the comments that were made, and consider some of the challenges, and maybe you can how you can help overcome them at a very high level. Okay, so for I said that I analyzed the different barriers that were used and the frequency of that. So I was able to run a report in the software, and these were the top 3 most frequently used barriers. So at a barrier count of 18, using administrative controls like sandwich boards, piping on stands, and some beams to close off certain sections of the yard. So that was a barrier that was used very frequently. So some of the degradation factors with that is that for some of those larger barriers, the mobile equipment might not be available to relocate them as the pedestrian moves. some congestion could be created when you're closing off larger sections of the yard. Cross-shift communication was highlighted as a challenge. Barriers not being available, or they can't be found, or they're broken. Barricades can be difficult to see during certain weather conditions. And maybe in some situations, other mobile equipment might actually move a barricade and they're not actually authorized to do so. Another frequently occurring barrier was direction and training to remove hearing protection while working in the yard. So the challenges identified with that is that the hearing protection isn't removed. It might actually be needed to perform the task, or there might be instances of existing hearing loss or impairment. So it's difficult for some personnel to be aware or hear mobile equipment anyway because of that impairment. And another one that was highlighted is the wearing of high visibility PPE and ensuring that it's in good working order. So there could be instances where the pedestrian doesn't wear the high vis PPE, or it isn't effective anymore. It could be worn out or dirty. So these were some of them that were frequently occurring. There's many more in the report. So if you want to learn more about those, just let me know. For the threats, so for the lumber activities bow tie, there were 28 threats that were identified. So 28 kind of different scenarios that were identified that could lead to a mobile equipment pedestrian incident. So it's a large number, and it's the part of that is the reason that there's so many different types of pedestrians. So there's so many different kinds of mobile equipment, and the hazard is very heavily influenced by the actions of both the mobile equipment operators and the pedestrians. The types of pedestrians that are most affected by the MEPI include a yard pedestrian. So we define that as personnel that are authorized to be completing activities outside of pedestrian control zones. So those are personnel like strip stackers, personnel completing cleanup, and maintenance people as well. Mobile operators becoming pedestrians. So someone, an operator who is running, say, a forklift or a truck, and then they have to exit the vehicle to conduct other tasks. That was another commonly occurring type of pedestrian. Mobile shop pedestrians as well, and kiln personnel were highlighted as a key group as well. So one of the recommendations that I saw in literature and that I would put forth is to help visualize and improve specific areas of your work site that are most impacted by mobile equipment at the pedestrian interface, to review your site plan map and identify key locations of threats in the facilities. So you would identify or you would create a site map of MEPI risk. Maybe some of you have done this, maybe this is an area of consideration for you, and you can use, for example, a color coding system, and that could indicate site areas that have minimal, moderate, and high MEPI risk. And this is similar to an approach that's used in combustible dust hazard management as well, is summarizing some key areas that have high dust generation and dust accumulation and low, so on and so forth. So that's a consideration as well to be undertaken here if you haven't already. Some areas for improvement that were identified by the workshop participants. I'll summarize them here at a very high level. So, and I have them listed actually kind of in the order of the hierarchy of controls. So it was great, Dave, for you to highlight, you were able to, or Shane, my apologies, reconfiguring the mobile shop, its location, its configuration. So in this instance, it was reconfiguring areas to have designated walkways at the mobile shop, creating more room to have parking along the wall and away from pedestrian areas, reorganizing aspects of the site to make it easier to establish eye contact and facilitate more predictable behavior by both mobile equipment operators as well as pedestrians. Move less frequently used equipment like spares, and create priority parking. And so really optimizing and prioritizing space for use. So that's kind of a good consideration if you have a small footprint available to you. So really prioritizing and optimizing that space. looking at opportunities to redesign and re-engineer to reduce the interaction. That's more of a trigger, a mind trigger overall to consider for implementing and integrating inherently safer design options. Considering where muster stations or parking areas are and where they're located in order to reduce risk. And then moving, those are, I would say, on kind of the inherently safer design spectrum, and then moving to some engineered solutions, considering the use of a photo eye system that illuminates a light path on the floor indoors. Considering changing the procedure for wearing high visibility apparel, so making PPE required in essentially all areas beyond a certain point, rather than only in designated walkways. So depending kind of on your company policy, this one might be pertinent to you as well. And considering decreasing or updating the posted speed limit to be more appropriate for certain high traffic areas. So an example and a figure that was suggested was less than 20 kilometers an hour. That was just an example that was proposed. Like I mentioned, I conducted a literature review of MEPI hazards in some other industries to help maybe identify some lessons learned and some other approaches that could be considered here. So Wilbanks et al. And WorkSafe New Brunswick recommend the use of broadband alarms over tonal alarms. So I would just encourage you to investigate and consider what type of mobile equipment alarm you are currently using. And if it's tonal, maybe consider broadband technology. Gunther and Salo outline an operator assistance system. And Shane, this is kind of along the lines of maybe what you were mentioning, audible warnings for an operator to trigger a reaction. So that's an administrative control, collision avoidance, guidance for road departure, reversing and path following. So an operator assistance system is an option, but just bear in mind it is still broadly administrative and would require input on behalf of the operator. HSE, or the Health and Safety Executive, which is an organization in the United Kingdom, they recommend, like I said, mapping movements and paths on a site plan. So that was where my recommendation of that came through. So to help clarify and visualize where pedestrians and mobile equipment interact. And that can help identify any opportunities to reroute traffic and improve site design. Michael and Gorsu, I think that was the last literature that I'll summarize here. They discussed injuries and reviewed and researched injuries by powered industrial trucks, and that included pallet jacks and forklifts. And while they did highlight that training and safe work procedures are important, they did emphasize the importance of improved layout planning for sites. So in line with that inherently safer design approach that we're encouraging here. A lot of these recommendations I've already touched on. So at a very high level, consider areas for improvement that were outlined here and examine and implement the feasibility of ISD options first, followed by those engineered and administrative controls. From the sawmill perspective, to continue Bowtie analysis of other key areas of focus and prioritization. So specifically, the Bowtie analysis of the log yard and of the production and indoor storage. Those were identified as other areas of interest. There was a specific threat that was identified that you may relate to, a new one of high material inventory, and that specifically is reducing visibility and maneuverability in yards. So this was highlighted as a high priority by a workshop participant. So I would encourage you to just explore, maybe some of the biggest challenges that you're having and prioritize the risk assessment of those. Develop a site map of the MEPI risk, like I mentioned, to help identify some ISD opportunities, complete or consider an ISD workshop. And as a disclosure, like I mentioned, this is a service that I offer. So we would systematically examine your site and identify ways to implement and integrate those 4 principles of ISD. And I would encourage additional research to be completed, looking at the other industries like airports, construction, mining, trucking, warehousing, just to identify, like we're doing today, sharing some lessons learned and any practices or strategies that could be considered and anything that's feasible to implement. So in summary, a Bowtie Analysis workshop was conducted to examine the MEPI hazard in sawmills. A couple of highlights, 28 different threats. They all involve a broad range of different pedestrian activities and mobile equipment. It was found that most of the barriers that are currently being used to manage the MEPI hazard are administrative, like we discussed. And there were a range of areas for improvement that were identified and some different approaches that were discussed. And some recommendations for future work include completing additional Bowtie analyses for areas of interest and really exploring and implementing controls that are higher on the hierarchy. So starting with inherently safer design, followed by passive engineered and active engineered. So I would like to acknowledge all of the workshop participants, including those production workers from the MAG companies and members of MAG for their active and enthusiastic participation and contribution to the Bowtie analysis. I also wish to thank Ms. Sherry Whelan for arranging the project and Bill Laturnis as well for assistance with coordinating everything with the workshop. And I would like to acknowledge the BC Forest Safety Council for funding this work. So I have some more questions for you folks now that we've pretty much wrapped up the slides, at least. I'd like to ask you, from your perspective, what are some of the biggest challenges or some of the biggest hazards that you feel like you're dealing with on your site for mobile equipment and pedestrians? So I'm going to open the floor.
The biggest challenge for my operation is compliance with administrative controls. It's one thing to put it into effect, have it as a requirement, but ensuring that people follow it. It can be the simple fix by having the no walk zone, but if people don't follow the rule and they walk through, they create the interface.
Yeah, that's a really good point, Dave. And Troy agrees, yeah. Yeah, and that was something that was highlighted, Dave, as a degradation factor, was whether, just different scenarios that would maybe cause personnel to not follow the safe work procedures or the different designated areas that are in place. Carl also agrees. Okay, yeah, so you're also having that issue as well, Carl. And Stuart, some larger inventories due to delivery challenges, creating cramped storage areas and sight lines. Yeah, exactly, Stuart. And that was that was identified by one of the workshop participants. So we really hope to circle back to do a bit more of a, do the risk assessment on that threat. So identifying any barriers that are in place to help manage that, and how to really, yeah, just how to deal with that. So it's good to know, Stuart, that I guess, well, you're not the only one, I guess, who's having that issue. I'm sure it's something that the entire industry is dealing with. So yeah, definitely echoing that that's a key area of interest and to analyze. Thank you. Anyone else have any kind of key challenges that they want to share? Okay, I'll move on to the next question. So of kind of the current hazard analysis process that you guys have to help manage this particular hazard on site, what are some of the challenges that you're having with it? Like, is there anything that do you know what you don't know? Are there gaps? Is there anything, I guess, that you think, maybe the process that you're using isn't as effective as you want it to be, or capturing all the information that you really feel like you need in order to address those gaps and those challenges that you're having?
I think the biggest challenge we have at my site is individuals understanding what a hazard is. So and it's interesting you asked this question, because what Workplace Safety North has done for my facility is create a training program which we're putting all employees through to identify or to help them understand what a hazard is and how to identify a hazard. Because as simple as it may seem to identify a hazard, most people do not pick up on the hazards. They think, I can walk through this area, and we'll just use this interface here as an example. I can walk through this area because I will watch out for the mobile equipment operator. But the mobile equipment operator is not even thinking about you, and they can turn immediately. We had a facility of ours in the US where a mobile operator of a clamp truck was moving in one direction. His brother, who was the supervisor for the department, went walking by. He didn't see his brother. He turned the equipment and backed over his brother and broke his leg. And these are two that they grow up together, that know the actions of another person. They're in the same department. One is a supervisor and one is an operator, and yet they created an interface that resulted in an injury. So I think hazard analysis or awareness understanding is key.
Yeah, that's a really good point, Dave. Yeah, and I think, like, so would you say, especially if someone is so comfortable and so familiar with their job, and they've been doing it for a long time, and they're working with people that they're familiar with, would you say it's difficult to maintain a sense of vulnerability?
Yes.
Yeah.
Yes, and that will come right from mobile equipment operators themselves. Now, you talked about one of the interfaces is as a equipment operator that now becomes a pedestrian because they get off their vehicle for one reason or another, but they're used to the department. They've got maybe two vehicles moving in and out. I'll just use our train shed, for example, for loading train cars. And two vehicles are moving around, but one gets off for a reason to fix a plate to access the train, or to fix something on their fork truck. They'll just come up with something, but they're comfortable in that department. Yet it is a no pedestrian zone. And they now just created the situation of being a pedestrian without moving out of the department, having everybody move out of the department, stopping all vehicle access so that a pedestrian can go in there to make the fix, which would be the logical way to do it if you understood hazards, understood the implications. And not everybody does. They don't get it. They create the situation themselves.
Thanks, Dave.
It's Troy. I think just to add as well, kind of picking back off Dave's thoughts, I struggle with, and I see there's a comment coming here now with the culture piece as well, that this all needs to be built into the planning and design phase of our operations, right? And in our organization, you know, we're ordering new pieces of equipment, whether it be a new press machine or a bottler or what have you. And you know, with COVID and supply chain challenges, I think someone also mentioned about the congestion, right? In terms of the flow of goods coming in, you know, our product inventory is increasing, but our space is minimizing. And the interface of the machinery as it relates to the space, the design, the people working around it, et cetera, the flow, all that needs to be considered, you know, at the very beginning. And I know, you know, we should all be doing our PSRs, et cetera, but getting ahead of it at that design phase, I think I'm not seeing enough of that, because we need to consider, again, the MEPI with our equipment. And I don't think it's on the radar across very high levels in the organization, right? I think it's something that is it's a systematic issue, I think, across the industry likely. And so now it's, you know, trying to come up with all these retrofits and, you know, changing, you know, things after the fact, which makes it much more difficult.
Yeah, all really good points, Troy. I wrote down management of change in terms of it's hard. Everyone is dealing with these new kind of inventory conditions. and how do you kind of respond to that and capture that within a management of change process? Yeah, and then it ties also back to Dave's comment about hazard awareness and understanding and knowledge. So yeah, some really key kind of topics are coming out here. Ed, I see you're unmuted.
Yeah, I was going to just comment that this is the human factor element, though. I don't think that people don't recognize the hazards. I think they recognize the hazard in many cases, but they find that for their personal assessment, they find the hazard acceptable. I can deal with this hazard. So you're dealing with the human factor in that scenario. So, you know, you get out of that machine and you're in an area that's not a pedestrian area, but for you, I work in this area, I accept this hazard, I'm prepared to deal with it. So I think people understand the hazards, but there's a level of acceptance. You know, for myself, if I put on a parachute and you asked me to jump out of an airplane, you'd have to throw me out. Where other people that I know personally jump out of airplanes with parachutes on a regular basis. So, you know, it's your human factor, it's your level of acceptance of the hazard, and that has to be factored into when you're addressing these issues, is that people will accept a different level of hazard for themselves.
Thank you very much, Ed. Yeah, really, really good points. Yeah, yeah. Yeah, especially someone maybe who, yeah, is it someone who's worked at the facility for 30 years? Is it someone who's worked there for a year or 6 months? Yeah, those different experiences and backgrounds, and maybe depending on what their like prior work experience is, and the knowledge of other incidents. And yeah, there's so many different factors that would play into someone's personal risk threshold. Yeah, really good points. So how do you kind of,
which is
sorry,
why I think that, you know, you have to have administrative controls, but I think at times that you have to move beyond administrative controls so that you take that ability for that person to accept that hazard and do something that, right? So you must put in place controls that prevent them from countermanding the administrative control.
Yeah, precisely, Ed. Yeah, just making it difficult and making, you know, it just taking away that reliance and dependence on human input and action. Exactly. Yeah, you hit the nail on the head. And we had a chat comment. Yeah, Tom, workplace culture shift is required when it's impacted by production pressures and historic work processes. So competing priorities challenge workers. Yeah, that was definitely something, Tom, that was brought up in the workshop. You know, mobile equipment operators, specifically forklifts, saying, you know, I am told to move briskly, and it's challenging. Yeah, competing priorities for sure. Yeah, and then the changing environment. Yeah. Yeah, and overall, the safety culture is a little bit of like, not a chicken and an egg, but it's like you need to have safety culture to help instill some of these practices, but in order to kind of help start implementing practices, you need to have a strong safety culture. So it can be challenging to gain that momentum in order to really start making that shift. And I have one more question, actually. We'll move on to the last one. So how do you think the approach that we covered today, Bowtie Analysis, moving higher up on the hierarchy, how do you think that this approach could help you in your role?
This is where the safety people should speak up here. That's no longer my role in my site. So
I could jump in with some comments from our perspective through Workplace Safety North. This really provides some leading indicators from an industry perspective and frontline workers and management and their experiences that are happening today. Historically, I know from a Health and Safety Association perspective, we've always dealt with lagging indicators, which don't give you the full perspective and are dated before they even come out. So I think this approach is very productive and really gives industry as well as the supports to the safety associations more background on where we can create the greatest impact and provide the greatest service to help industry in eliminating these injuries.
Yeah, thank you very much, Tom.
I have to say that it opened my eyes and made me see it from a different perspective. Instead of looking at it through the front door, look at it through the sides of the windows, back door, and see what you can create into a safer way. You know, add those indicators, see what else, get communication, see what can be helped out there, and just go from there and make sure everything's safe.
Great, Shane. Thank you.
That wasn't Shane, sorry.
Oh, sorry, that was Carl. Thanks,
Yeah.
Carl. Thanks.
Yeah, you're welcome.
Yeah, so as I reflect on the bow tie, the one thing I'm curious about and maybe missing for me is it's a great analysis tool on all the hazards by threat. But where's the connection to risk? Like when you talk about identifying high risk areas, like it's not jumping out for me there.
Yeah, it's a really good point, Shane. So we didn't complete like a risk matrix. Are you asking about a risk matrice?
Yeah, of some sort. So you mentioned the map and identifying the high risk areas. That didn't really, I don't know how the bow tie will help me with that. Yeah, that's my question.
Yeah, no, that's a really good point, Shane. I didn't really do too much of a deep dive about that here. So what I would encourage is if you were to have the whole bow tie or conduct the bow tie for your specific facility, then you'd be able to look at the different threats that you have. So maybe give an example. Well, at a high level, look at the threats, identify where kind of your key areas of concern are. So in terms of risk, what's going to be the highest likelihood and what would be the most severe. So doing a bit of a risk matrix yourself, looking at those different threats and kind of where the biggest areas for concern are. So is it your kiln? Is it your mobile equipment shop? So just prioritizing those areas that are identified in the threats and mapping it yourself for your specific site. Does that make sense, Shane? So yeah, I didn't really cover it in here in terms of kind of the next step that you would take to customize it for your site and really implement it. Does that make sense?
Yeah, I think so. I guess what I'm hearing is that the risk analysis is a separate process and you lean on the bow tie to guide you through that process then?
Yeah, exactly. Yeah.
Okay.
Yeah. Yeah.
Thanks.
Yeah, you're welcome.
Can I just add as well to Shane's question? Great question. I was sort of thinking the same as well from a risk assessment standpoint. You know, obviously with mobile equipment, I mean, the severity or the outcome or consequence of potential impact could vary. I mean, my natural inclination is to, you know, always assume worst case scenario with a lift truck or piece of mobile equipment. Any advice from you or the group as to when identifying risk, like other than looking at the probability of occurrence? I find tendencies that most things regarding that mobile equipment are going to be naturally high risk anyways. Like, are there certain nuances within you assessing the risk at that interface that will change whether or not it's medium or low or high, other than the probability of occurrence?
Given that I don't have intimate knowledge of past incidents that have occurred, but yes, assuming what you have, Troy, that basically assuming that if there is an interaction, then it's going to be fatal. Then the only other variable is your probability. So mapping those areas of highest traffic, i.e. highest likelihood, that from a risk assessment perspective, that's kind of what I would say would be how you would assess the risk. But that's just based kind of on my knowledge. That's what I would say. Would anyone else in the group have any other input?
Yeah, we're facing the same challenge. It seems to default to fatality, and then all of a sudden everything's high risk. So we talked a bit about speed maybe, and then I think maybe it's more around those cascading domino effects. So if there's an existing barrier in place, but there's still a potential for a package to fall and seriously hurt someone, then those maybe it's more if there's existing barriers or some control in place, maybe the likelihood of fatality is less. But yeah, that what Troy mentioned is the same, kind of resonated with me. It's what we're going through as well.
Yeah, and at a high level, kind of within the scope of just extending beyond the scope of this work to take that next step at a high level, that would be my understanding, and that would be my approach as well. Unfortunately, it doesn't, I know it's difficult because the saying is when everything is important, nothing's important. So it obviously makes it very difficult to prioritize. I understand that. So unfortunately, I don't really maybe have any better of an answer, any other insight in terms of any other kind of nuances that you could, any other nuances for it.
Yeah, no, that's actually helpful. Thank you. I'm embarking on my first sort of traffic assessment, if you will. And so I like the idea of, mapping out the threats and looking at the frequency of traffic in certain areas and starting from there. So thank you both.
Yeah, you're very welcome. Yeah, and if you have any questions, just let me know.
So Kaylee, I just wanted to add something for question number 3 that we did with the pellet operations. Once you've identified your degradation factors and your degradation factor controls, we went the extra step to identify which were the critical controls, and then we did the analysis on the critical controls and how well those are being managed. So I think in terms of this approach, when you start to drill down to those levels, and at some point you have to pull out the important ones, and that's why we went through the process of the critical controls, the ones that you need to have working all the time. It gave the aha moments to some of the operations we were in, and I can see the manager of the operations busily scribbling away on his pad of paper and then going to his supervisor or somebody afterwards and saying, we don't really do that very well. We need to look at this and decide how we're going to do it better. And I think that's, to me, the biggest value of this type of approach is when you've identified what are the critical ones I really have to have working.
Yeah, thank you very much, Bill. Yeah, exactly. Yeah, that kind of ties in a little bit more to Troy's and Shane's question. I mean, so if you identify kind of the key areas of concern and then, yeah, prioritizing the key barriers from there. So whether it's designated areas, if it's, we really need to work to reconfigure a certain work site, like work area. Yeah, that kind of takes it to that next level, looking at the critical controls. Travis?
Just talking about the risk, I just want to remind that there's 2 parts to that part of risk, the probability and the severity. And the point I've been pushing with our organization is the severity is always high. You interact with a forklift, the severity is going to be high, whether it's doing 5 kilometers or 20 kilometers an hour. But the probability is the part that we get to work on most, is how frequent people might be in that area or how frequently they might interact with that forklift. Is changing that probability. Then previously was talked about people not following procedures and perhaps walkways. Well, then perhaps we need to look back at the design and say, well, you need to put up barriers so that they would be forced to literally climb over a walkway. So now they're choosing. But if it's a case of following painted lines, yeah, we're humans. We're definitely going to diverge from that. So.
Yeah, really good points, Travis. Yeah, so that's the difference between having Yeah, painted lines and cement barriers, for example. And I think now that we're discussing kind of likelihood, and you mentioned speeds a little bit more, I think that did come up in the workshop, basically assuming, yeah, like it's going to be a severe incident, whether exactly the mobile equipment is going 5 kilometers or 20. So yeah, that discussion was had as well. So yeah, all really good points, Travis. Thank you.
And it would be great for those talking earlier. Sorry, my mic wasn't working, so that's why I haven't said anything. But perhaps the Vision Plus, as you'd mentioned, was an administrative control. But if there was a system designed where it detected a pedestrian and forcibly slowed the machine down, so now perhaps the person was 30 yards away and it was doing 10 kilometers an hour, it would slow it down at the slow enough speed to ensure that that never made contact. If person stepped right out in front, perhaps it's slamming on the brakes. Obviously, we're going to have other issues with dropping loads on that person and so on. But that would be a bit more of an engineering control, perhaps. And so.
Yeah, exactly, Travis. Yeah, so if the machine automatically reacted to detecting a pedestrian, exactly, that's active engineered. Exactly. Yeah. Yeah, but it takes up that human element of the mobile equipment operator having to react to someone. You know, the machine is doing it instead. Again, not perfect, you know, detectors and sensors fail, but it is moving higher up on that hierarchy. So yeah.
And one more comment I have with PPE, just in case in some of the comments I've heard, if I can't see you, I can't see you. Doesn't matter how much bright clothing you're wearing. So, you know, PPE in that point, really, it's certainly a warning to say, oh, there comes someone in the distance. But incidents that I've been privy to, when they can't see you, they can't see you. That's just how it works. Doesn't matter how much PPE you're wearing. So that has to be considered when you're thinking of PPE. It might be an awareness in the distance. And another thing we keep doing is we're putting all of this back on the operators. So we're putting bright PPE on the pedestrians, but it's really the operator's responsibility to see that pedestrian when we do that. And when we put in systems to warn them of pedestrians, we're putting pressure back on the operators again. So then you've got to really start to consider it's not just the interaction, but the workflow and process of where people are moving. And if you look at a lot of forklift incidents or accidents, it really is those moments where people were surprised. It was that person stepped out of a place they should never have been. It was the change of workflow. Oh, we just added an extra forklift, and for 3 months there wasn't that extra forklift. All of a sudden there was. He changed. Now he hits a pedestrian. Or we were in a rush and we just get this guy out there to go and put his hand on the load type thing. So when things change, that should be really something that you talk to your operators about. Conditions have changed. Same as when it rains or snows or, you know, things like that happen, then you start to say to yourself, or when you're coming from on a highway at 100 kilometers an hour to a town of 60 kilometers an hour, the first thought you should be really trying to practice having is conditions have changed. Doesn't mean that it's safer because it was slower. It now means that there are other people who could be jumping out on side roads. So having that mindset when talking to operators and working through this helps.
Yeah, all really good points, Travis. So again, bringing back that management of change. I mean, management of change is obviously not only like changing a piece of equipment, right? It's change of personnel, it is change of seasons and inventories and so on and so forth. Yeah, it's much more complex. So yeah, how do organizations adapt to those different changes and pressures? Yeah. Jim?
Thank you. I've not heard too much about that. The word my colleague just used a moment ago, workflow. In the oil and gas industry, for example, even a simple well site, which is a relatively small site, it's mandated that it must be a merry-go-round arrangement for the vehicle traffic. You're not supposed to have to reverse on a well site. You're supposed to be able to drive in and drive out. That's the way. Even if it's a single operator, he's supposed to drive in and make sure his vehicle is ready to exit. So he's on his way out before he leaves his vehicle. That person leaves his vehicle, their vehicle. In the power station I was at for 17 years in England, everything was merry-go-round. All the train activity, there were 45 trains a day, and it was all come in and go out. There was never any reversing. In the vehicles, about 120 truck activities, they were all merry-go-round. At the oil and gas plant I worked at in central Alberta years ago, all the truck traffic merry-go-round. Now, I know our sites are 100 years old. I know our sites are tight. I know we like to stack up logs because it's a season where we need it. But if we just put it to 2 hard box, I think we're missing an opportunity here for a real hierarchy of control. Get the sites merry-go-round, get that workflow going the right way, and don't change the workflow. It can help. That's my thought for the day.
Thank you very much, Jim. And that's one of those other industrial learnings that we're really trying to leverage. So thank you very much for bringing that up. So yeah, like identifying those other types of practices that are being used in other industries that have mobile equipment, how are they handling it? So thanks for sharing the merry-go-round approach. And it is definitely an ISD perspective. Yeah, thank you.
Yeah, I'd like to add to what Jim said. I fully agree with that, and maybe I'm stating the obvious, but we don't have to make it merry-go-round, one merry-go-round for the whole site. You could have 4 merry-go-rounds for that site. You could have sections of A, B, C, and D, where A goes that way and no one else enters and does it differently, and B. So just keep that in mind. Sometimes helping that to think out of the box can make a huge difference. A log yard could be split up into different sections. The shipping yard could be into different sections, and how that works. So sometimes we want a one-fix-all solution for these, and it's just not how it's going to work.
Yeah, great points. Yeah. Yeah. Anyone else want to add anything? Lots of great discussion.
Yeah, I gotta say, when I used to work at a sawmill before I worked at Nechako Lumber, and our way to know about our pedestrian interface and our mobile equipment is if there was somebody on foot or if there was a company vehicle that was going through our rough yard, dress yard, kilns from planer to sawmill. We always got on the radio and said, mobile vehicle going from planer to sawmill. So it gives the forklifts that alarm, and they know, okay, they're coming from here. Come a little bit slower around the corner, just in case if that person's going by at that time. It's just if communication is a really big thing, and that's what I've noticed a lot lately. If you don't have it, it could cause more hazards or more risks.
Yeah.
Sorry.
Yeah, no, really good point, Carl. And communication and improving communication was talked about a lot in the workshop. Bill, I might ask you to chime in as well to this. They were kind of looking at, the discussion of any opportunities to actually use cell phones was actually kind of brought up. Everyone has them. They're, potentially more reliable than radios in some ways. Looking at how that could be tactfully and strategically used, that was brought up. And overall, Bill, I think there was a suggestion around a bit of a communications, like a centralized, I think they referred to it as a bit of a storyboard to kind of, so when people were starting their shift, then it was an easier way to communicate like kind of what was going on, really, just so everyone was on the same page about different activities that were going on in the yard. Bill, do you have anything you'd like to add to that?
Yeah, they talked about the storyboard, but a couple of the forklift operators also talked about how they get out of their forklift to put the blocks on the loads when they're stacking the lumber, and they don't necessarily hear somebody calling out saying they're going through the yard. And so they tend to rely on other people, that other forklift operators that might have seen them get out of their forklift to tell them that hey, somebody's going through the rough yard from the planer. And so, you know, they did have a bit of a wish list that came out of it, in that, you know, it'd be great to have something in the forklift that when somebody called out that type of acknowledgement, and of course you need digital radios to do that, when they get back in the forklift, there's a message there for them and they can acknowledge that message. So there was some discussion on how do we improve the communication, not just with people saying they're going through the yard, but there's some type of system where a forklift driver can actually acknowledge they heard the message, somebody going through the yard.
Thanks, Bill. Yeah. Carl?
Yeah, no, I was just going to say thank you.
Yeah, but no, communication was brought up. That was discussed a fair bit, Carl. And yeah, challenges with radios and kind of how that could be improved. Yeah, was covered.
Yeah, or even like if it comes down to, you know, if you're knowing you're getting out of your forklift, just have a mobile radio with you, so when you jump out, you have it on you at all times.
Yeah, exactly. Yeah, those kinds of options. Yeah. Well,
Yeah.
Thanks for sharing. Thank you.
Thank you.
Yeah, you're welcome. Ed?
I just want to comment that, you know, one of the issues with communication, obviously, is that there are barriers to hearing the message. So I think one of the failures that you have is the person that is putting something out on the radio doesn't wait for an acknowledgement that message has been received. So I think it goes back to the person that is putting that message out there, that they need to receive that acknowledgement that message has been received by the person that they're sending it to. And until they receive that message, they should not proceed.
Yeah, exactly, Ed. And there's a type of communication that's used in the nuclear industry, and it's called three-way communication. So we brought this up, and some of the forklift drivers said, oh, I think that's going to maybe potentially complicate things. But yeah, you send a message, you repeat back the message that as you interpreted it, and then the person has to repeat it back. So it's this repeat back approach, the three-way communication. So the message is sent and it's received and interpreted properly. Yeah, it's rather than two-way communication, which is like, well, did you say correct or incorrect, for example? Yeah, and not having the acknowledgement in other situations. Thanks, Ed. Travis?
Yeah, sorry about that, Kaylee. I forgot I wasn't muted.
No, that's okay.
So I have been trying to work with a company that had mentioned that, and my biggest thing in our sites is keep pedestrians away from forklifts. If there's no need for you to be around them at all, then you shouldn't be. So putting up those barriers, the walkways and work areas, workflows, that process. But if you do have people who might have to be working in, say, a shipping yard and want to take inventory and there are still forklifts in the area, this company has it where the pedestrian actually wears the warning signal, and then there's something on the forklift and it'll warn the pedestrian, a forklift is 30 yards from you, a forklift is, so then it's giving the pedestrian the option to lift their head and say, okay, you know, maybe then call the forklift on the radio, hey, just make sure that you know I'm here. So we're putting that onus back on the pedestrian, not so much again onto the operator who's thinking of, you know, the flow and driving the equipment, and plus all the other noises that we give them. So.
Yeah, that's a really good point, Travis. And is that the like the RFID tags in helmets, or is that another type of device?
It's another type of device. We haven't purchased it or tested it. It's just been discussion. We're really looking into a communication device in noisy sawmills so that we can ensure our young workers get a bit more of a communication process going, rather than have a look at this dangerous piece of equipment that could kill you. Oh, hold on, let's go back to a quiet office and discuss it. So
yeah, yeah, really good. Okay, thanks, Travis.
So Kaylee, we're coming to the end. If you want to finish off the questions, I think.
Yeah. No, that's it for the question. So kind of to wrap up the presentation, and really the motivation that for us being here today is for a statistic. In the past 10 years, in the province of British Columbia alone, there have been 550 struck-by incidents, and that's approximately one per week. So as we've talked about and everyone's working towards today, let's enhance risk reduction approaches in the different work sites and work to eliminate mobile equipment incidents. So thank you very much for attending today. If you have any comments or questions, any follow-up information that you'd like, please feel free to touch base with me, shoot me an email, or give me a call. I'm happy to talk and answer any questions you have, and I hope to support you. Bill?
Thank you.
Thank you, Dave.
Right on, thank you.
Thank you.
Thanks, Kaylee.
You're very welcome.
Thanks very much.
Thank you. Great discussion.